Wrong button. Hello, it's time to go, the reincarnation of that meeting. Thanks to Timo for restarting it. And this is the first one in the new season. And I don't know what to talk about. Let's talk about what I'm working on. So it's this issue with CI routing timeouts again. Some customers are getting errors. Agent not found. Is it connected? And this is a screenshot of the old dashboard. That's the new dashboard. You can see this graph should be 0 or almost 0, but there are occasional spikes, and this is not good. It was worse. We have fixed a bunch of problems, and yeah, it's much better now, but still happens. So no, it's not right. And today I found yet another problem, which is looking at the profiler. We see that delay in this. Interesting. It's showing something else again. I'm not going to do this. Now it's showing tunnel registry. Something's wrong with this UI. Look, if you do all, it's showing me. Okay, here it is. This is okay. And this is okay if you look at it like this. But if you look at it like this, top 1%, we can see that this thing can take up to 1.5 seconds or almost 2 seconds.
So unlock?
Yeah, trying to lock the mutex unlocked is just the method that counts the delay, I think, because this metric shows the delay. We are looking at the delay of that mutex, basically. So it's a lot for this. It's not supposed to be blocked here, basically. I mean, some mutexes are okay to block and wait for a while, but this one is not one of those. Shouldn't be. So I expected this after one of the fixes, but then profiler was not showing this. And now today I found that it is actually showing this, and it's not okay. So reverse tunnel. Yeah. And the previous version was even worse. This thing was blocked for up to like 40 something seconds. That's crazy. I don't know how that even is possible. Yeah.
Is this GitLab cast?
Yes.
I see.
This is the profile for GitLab cast in production. So what this thing does, tunnel registry, its job is to register tunnels from agent K in Redis and to find those tunnels across all cast instances. So cast instances can see each other's registrations of tunnels for agents. And then cast can route an incoming request to itself or another cast instance based on this data.
I see.
So the problem here is all that. Tunnel register, this is the thing. So there are two main methods. Handle tunnel, this is the one that accepts a connection from agent and registers it. And then it blocks until it's cancelled or the tunnel has been picked up and used, and then it returns a nil or an error, and that is returned. Then the other important method is to find the tunnel for this agent ID. And we try to find a tunnel in this class, basically. Or we remember that there is a request to find the tunnel for these parameters, agent ID service method, and where to return it. And then we return it. We return the find handle. It's like a handle for the find operation, basically. You can block on it to get the tunnel. Doesn't matter. So what matters here is this mutex. It serializes, so it protects these three maps. And tunnel register is also called when the mutex is held. So here, for example, this is locked, register tunnel locked. So it must be called with the mutex held. So we hold the mutex here and then call it to register the tunnel. Then there is also, it's also called here to register it. And then there is unregister, this method, which is the same. It's called with the mutex locked. And so the problem is there are lots of agents establishing lots of tunnels. So they all try to register and register, and all of that creates contention on the mutex. And what makes it worse is that the register and unregister are IO operations. So we need to talk to Redis and to set a value there or to remove a value from a hash. So as an optimization, actually, register tunnel and register tunnel only set the value once. They don't. So if there is a class URL for this agent, class URL of this class for this agent is there already, then we don't need to do this, basically. No IO is performed. But this is still causing some problems based on profiler. So I think this mutex is the bottleneck, basically, and that's what we see in the profiler. So what do we do about it? Do you have any ideas? Any suggestions?
So if I understand correctly, that map data structure is shared among the thread. So we use sync mutex to synchronize them, right? Like these three data structures,
Yes,
tons by agent ID.
Yeah, also
find request by agent
this
ID.
This one. Register is also protected, kind of. Well, we call it within the mutex section.
I see.
Yeah. So maybe action code it like this, but it doesn't.
Just general idea is maybe we should think about how we can minimize the critical section, like starting mutex lock and the end of transaction, we unlock the mutex, but we need to minimize the transaction, right?
Mm-hmm.
Only we have to lock only when it is critical for the
Mm-hmm.
data structure. So, but this is very general, so I'm not sure if it works in this case.
Well, it does work. We used to, where is it? We used to, looking for something. Well, it's not here, it's in the tracker here. So we used to run garbage collection in the hash synchronously while holding a mutex, but now we prepare for garbage collection while holding the mutex and then run it without the mutex itself. So this helped quite a bit.
I see.
So this is a way to minimize the critical section. But all the other parts, I don't think there's a way to minimize the critical sections further. So any other ideas on what is possible?
Other idea is, so we find this issue at the production, right? The reason why we found it in production might be because there are many data, too many data in the production. So can we reproduce it in locally? And so that maybe we can test it and find some bottleneck easier. Just an idea. Like writing some test case with like generating a lot of mock data and yeah, run it and see.
That's actually a good idea. I haven't tried that, but we see that from the profiler that this mutex is seeing some contention. So what I actually want to do is there's a technique called log striping. It's the idea is to partition the data. What? Okay, it wants me to. The idea is to partition the data so that each partition has its own mutex.
Yes, partition.
And then instead of one mutex, everybody tries to grab. You have n mutexes, the number of partitions, and clients grab some mutexes depending on the client ID. In this case, partitioning key is client ID and agent ID in this case.
I see.
That's how you can do it. So theoretically, each agent ID only needs to be operations for each agent ID only need to be synchronized, serialized for that agent ID. But that can be difficult to actually implement. Just because of how this is structured, this expiring hash is structured. So yeah, this is something that is a wrapper on top of Redis hash, which is just a hash map. But it's a two-level hash map. So key is a key of, by that key we find the hash itself in Redis. Then within that hash we have key within the hash. and then we have value for that key. So it's a two-level hash basically, or a hash of hashes if you want.
Very interesting. But
so
what brings you to this like two-level hash? Very interesting.
So we use it in multiple places. First, in this case, that's where we store tunnels by agent ID. So key is agent ID, and the second key within the hash is the CAS URL, and the value is nothing. So it's a set basically. It's not a hash, it's a set in this case. So it's a hash of sets where first key, first level is agent ID, and the second is a set of CAS URLs for this agent ID. So that way we can look up a list of CAS URLs that have a connection from this agent ID. And there are a few other places where we use this for where value is not new. And yeah, so the purpose of this is to add expiration to the second level of mapping, because in Redis you can have an expiration on the whole hash, but not on a key value pair inside of the hash. So
I see.
We just implement this ourselves by putting a time to live in there and periodically scanning everything and deleting what has expired, and or updating what hasn't expired, what we don't want to expire.
Is this newly added by you, just for this?
Yes.
I see. Wow.
This is yeah, we use this in several places. Well, at least agent tracker, and tunnel tracker, and somewhere else, I think. I don't remember. Show me that. Anyway, so currently this is a single structure here in the Redis tracker.
Yes.
For all the agent IDs. And then in tunnel registry, we also have a single structure, a set of tunnels and a set of, well, not set again, a hash of sets, basically. And this is a hash of sets as well. So tunnels by agent ID and find requests by agent ID. I mean, it could have been a list, but it's a set so that I can delete from the set by the pointer, basically. Just to simplify it. So what I want to do is I want to partition all of this by agent ID.
Understand.
And then each partition will have its own mutex. And that way everything will be more complicated, but we will get rid of the contention.
Yes. Then the maximum number of mutex will be the number of agent ID, or some number we can configure.
Yeah, as I said, we don't want to do a pair agent ID because it will be difficult to reshuffle the code like this. Yeah, this whole expiring hash will not work like this.
That's
yeah, I haven't came up with a way to do it in a nice way without completely rewriting everything here, but I don't want to do that. No, it shouldn't be necessary. So what I'm thinking is just using maybe, so I will prepare this striped value thing, which is, you can see the good explanation of this whole idea in GitLab actually. It's a Java library from Google with various building blocks. And this is the idea basically. So this allows the program to dynamically select trade-offs between concurrency and memory consumption. So what I've done here is basically a single stripe is this mutex plus a value. Value is some value using a generic. And then we have a list of those things. And we use power of 2 to use bitwise operations to get the remainder of the division instead of actually using division and remainder of division, because that's much faster. We just AND with a mask and get the lowest significant m lowest bits using just AND with the mask, and we prepare the mask here. So this is all bits set, maximum integer 64, signed integer. So it doesn't matter. So all bits set, then we move it left by n, that unsets the lowest n bits, and then we negate that using bitwise not to set the lowest n bits, basically.
I see.
And or we could move right with 64 minus n, something like this, but doesn't matter. Yeah, so this is our mask, and we just pick the slot in this slice, and in that slot we have a mutex and the value. This is our striped value, mutex plus data. Not just the mutex, but mutex plus data. It's just more convenient to use. And we have a lock for this ID. This will be the agent ID, and then a lock for the key, and then try lock as well, because why not? So then I want to use it here, and the value will be Thanos. I think. What do you think about this? Is it too crazy?
And
then also the register, because this thing requires GC and refresh. So I'm at the same time I'm removing a mutex. Let me show you. I'm removing the mutex from here, from registracker, and removing garbage collection and refresh from here as well. You see, removing the mutex, because now the registry will be responsible for calling the garbage collection and refresh, because it kind of doesn't make sense to hold the lock in a nested way. Like, why have the lock in the second layer if the first layer holds the lock already, always? So I decided to remove it from here and to have a single layer of locking to simplify things and speed things up as well. But yeah, I'm thinking of doing like It will be that. Maybe I don't need 8 bits. Yeah, okay, it wants the type parameter. Okay. Fine. No register. And we need a lot of these registers. How will that work? Mhm. Hmm. Anyway, so I'm trying to do this crazy thing to partition all the state, but
Yes.
it should reduce the problem to okay. This will be for the register, so I will do the log for for ID and what is it? No, it's for page. And then defer the same thing with unlock, something like this, and then this will be used here in the registration. Yeah, this looks messy because yeah, I have only started trying to implement this idea. This may be not, this will likely be not separate fields, but actually maybe a single field. So sorry, single struct with a single striped thing. Yeah.
How did you decide this N8 in the
I don't
line?
know.
Yeah.
I mean, good to have some space. Maybe it should be like 6 or 64 partitions.
I still don't fully understand that bitwise operation, like mask. So giving here the number 6 or 8.
So this will be this is my playground. No, this will be 1 shifted by 6 will be 64. Yeah. So 64 partitions.
So 2 to 6, I guess. The
yeah, 2 power 6.
2 power of 6. Yeah, I see. So it will create 64.
64
Yeah,
slots, 64 partitions,
partitions.
each containing the state that we want to partition.
Yeah.
Yeah, maybe it will be a single struct value, and then there will be, I don't know, state, and this will contain all of that. For this ID, something like that, and then we'll have, I don't know, like this. Yeah, this will be striped mutex around these things. And when we need to grab a lock, we'll do that. And then this will be our, everything. Yeah, this needs to be updated. Let's say, I don't know, yes, maybe. This. I don't know. I will come up with a better name. By the way, this needs to be, does it need to be a pointer? No, it can be passed by the. And then we will have everything that works like this. Might be, yeah. It should be fixed this way.
Another question. So you have, could you go to the data structure of S state? S state? Yes. What actual value or struct? Wait. Like, for example, this tons, right? Inside the tons, so key is the pointer to tunnel. And having what kind of struct do they have?
This?
Yes.
It's an empty struct, meaning that it's a struct with no fields. So nothing is in there. So this means it's a set basically. It's a map with some keys, but values are empty. So it's a set. Set is a hash without values.
I see. So is it same for the tons by agent ID?
Yeah.
Inside the map?
It's a typical pattern in Go where to build a set, you just use a map where values are struct, empty struct.
I see.
And I think compiler actually optimizes this to not take any space for values. So it actually has a map that only has keys and has no values in memory.
Okay, I see. Thanks. This is something very technically challenging, and yeah, it looks very, to me, it looks very complicated, but very interesting.
Now it unfortunately has to be complicated like this to what it does. I don't know. Would be nice to simplify it, but I don't know how to simplify it further.
Yeah, but I think that's very nice approach to having like many, like increase the number of partition, and so that maybe, yeah, like data. Yeah, I think it's kind of data race, right? So maybe we can decrease the load of data race.
Yeah, we can decrease contention by having more mutexes, basically, by striping the mutex into multiple separate mutexes. And I'm thinking 64 should be okay, but maybe even more, because Memory is not that expensive. It's not going to use a lot more memory, but if we can reduce contention a little bit more, then a little bit more memory is okay. If we use a little bit more memory, that's probably single digit megabytes, maybe even kilobytes. I don't know. We can estimate that, but I don't. I mean, it's all of that will be less than 1 megabyte. So who cares? It's not a lot.
True. I will have a look about that Java library.
There they have a lot of interesting things there. But yeah, lots of that is not applicable to Goa. People just make do without those interesting collections and other things, because it wasn't possible to write such libraries before before generics. So with generics, people will probably start writing fancy collection libraries. We'll see. Okay, this is what I have so far with this issue. I only started working on this several hours ago, so as you see, it's not gonna compile.
Yeah,
but I wrote some tests for the value, like locking and unlocking, and then trying to do the same index with try lock, and then same stripe, like 1 and 5 will be in the same stripe for 4 shards. So 2 bits have 4 values. So 5 is naturally, will wrap around. And will have the least significant bit set only, and that's why 1 and 5 are in the same stripe. So if you lock 1, try lock 5 should fail to lock because it's the same stripe, and we already hold the mutex for this stripe. Once we unlock it, we can lock 5. And that once we'll have locked 5, we cannot lock 1. And, yeah. And locking multiple stripes is okay. Actually, we can
interesting. Yeah.
Lock different stripes. We can do even like this. Lock. Should be okay as well. Well, we can also use 0 here for consistency. Wait, no, sorry, 1 and 5 are the same stripe, yeah. And these are different. Yeah. Okay, I'll probably continue this tomorrow.
Okay, yes.
Do you have any other questions? Anything else?
I think I already asked, yes, enough questions. Yeah,
Okay,
thanks.
then.
Yeah.
Stop recording.